Hello, my name is Caden Leniger.
My name is Zachary Stanley.
I'm Simon.
And my name is Esteban Vega. So this is our final project. We were tasked to use two different communication protocols, a Wi-Fi module and an I2C module, to automate the operation of a door lock. To do so, we use the Arduino interface that the Node MCU uses, and we use that to communicate with the I2C module, and in turn that communicates with the servo motor and it operates a door lock. So the purpose why we chose this would be to create different ways of how we could enter our home. So it would be beneficial for those with disabilities.
So for the mechanical aspects of this project, we have our 20 kilogram servo motor that can turn up to 20 kilograms, and it has a gear on top that is connected via a D shaft into the quick set lock. The D shaft was 3D printed and is screwed into that servo motor that you can see right there. So if this deadbolt was to be mounted on the door, the actual mechanism itself would be steady, and the only thing that would turn would be the deadbolt inside, which is exactly what we'd want for an installation. Moving on to the MCU code, Zach's going to talk a little bit about that.
Yeah, so the MCU code is written in Arduino, but it actually involves some HTML code that is provided. So the top of the code here has the char val, that is the wireless communication. That is going to be the character that's going to be communicated between the PIC and the Node MCU to make sure that there is a signal that's supposed to be sent and an action that's supposed to be started. Beneath that, there is the HTML code that will start writing the page where we will go to turn on the motor and start the door unlocking mechanism. And down below that, scroll up a little bit, Caden, to the last picture. Yeah, so here, it's important that the serial.begin line there has 9600 in it. That's the baud rate that the PIC and the Node MC are going to be using to communicate. After that, it is going to set up and try to connect to the Wi-Fi network. So up earlier in the code, you could see that there was a point where it asked for the SSID for the Wi-Fi and the password. It uses that to connect to the Wi-Fi, and whatever device that is used to access the web page to turn the lock also needs to be connected to that. And once it has connected, it'll let you know in the serial monitor that it is ready to go and that it can start communicating. So scroll down a little bit. Down here, we have the actual loop for the code. It is going to be waiting to get a signal from the PIC to have its communication. Then it'll start here. And once it has received information from the web page, it will send another character back to the PIC. And the PIC is waiting to receive that information before it executes its code. And if we go on to the PIC code, you can see that the top has a value of 12 in the SPBRG. That comes from the baud rate of 9600. And so now this is going to get into the PIC code in MPLAB.
So for the PIC code in MPLAB, we basically leave off from where Zach was saying his node C, and then we go into the PIC code where we gather that binary input from wherever he left off, and we grab it in the PIC microcontroller and start our execution of the code in order to I2C communicate. So we have some loops in here that will watch that input of the RB port from his node, and as soon as we receive that it was a 1 or a 0, we determine that, okay, we need to open or close the lock. So down here, I'll scroll down to where we start the I2C initiation. We initiate the I2C protocol. We have to declare the address. We have to idle it. Then we can go to I2C start and I2C write. I2C write is where we'll initiate the write of the address to the actual device. And then we also need to set the frequency at where we want to turn the motor. and that's via the duty cycle, and we can tell it to turn 100 degrees right and then negative 100 to go back, and those are our lock and unlock positions. When we're done sending the I2C, we need to conduct an I2C stop, and then from there we can clean up the pins, and that's it. So for the wiring diagram of the project, we have the node MCU that is connected to TX, RX, and ground of the PIC. The PCA 9685, which is the 16-channel servo controller, SDA is connected to RB0, SCL is connected to RB1, and EO is connected to RB2. EO is going to be set to 0 in the PIC code in order to enable write for I2C. This channel is grounded and supplied via the 5 volts of the PIC, and the servo motor is connected, has its own power, ground, and signal wire. This PCA 9685 is externally sourced by a 12-volt source in order to run the servo at the proper voltage. As you can see down here, this is kind of the same wiring diagram of the PIC and what we used as reference for this project.
Okay, so this is basically a representation of how the two modules communicate with each other and the Wi-Fi. So when we start and initially initialize both the PIC and the node MCU, they're both going to be waiting for communication from each other. So, and first the node MCU is going to be waiting for communication from the web page to see if the button has been pressed. If the button has not been pressed, then the node MCU continues to poll inside of the Arduino code to see if the button is pressed. And then when it is pressed, it is going to send a character to the PIC, which lets the PIC know to start its part of the program. It's going to assign the global I2C address. It's going to set the frequency, specify the slave address, and then configure the SDA and the SDL as inputs. And then it's going to initialize the start condition for the I2C communication, and it is going to write to the I2C register whether to lock or unlock the servo motor, which is going to turn it one way or the other. And then once it's completed both of those, it's going to stop the I2C communication, and then it'll go back and start polling inside of the Arduino code looking for that communication from the web page.
So here on the screen, you're going to see a video of the demonstration of the project working. So there's that lock and unlock button. And here's just a little overview of the wiring we have going on in the setup. All right, so we're going to hit the lock button. So as you can see, when I'm clicking the button, we're unlocking and locking, and the servo motor is turning. And this is all happening over Wi-Fi. All right, and to conclude.
Okay, so finally in this project, I guess we successfully produced an automatic door lock, and which control the electric path and the motor by two communication protocol, the I2C and the Wi-Fi model. And we used this step motor to control the minimal operation required to operate the door lock. And by using this method, various ways of entering the home can be automated. And this project will also be beneficial for the disabled because it can provide a way to unlock the door for people without leaving their seat and or with minimal effort. And once now people log into the Wi-Fi network, they can also interact with the interface of operate to the door lock through the web page and gain access to the premise. So I think that this class allow us to actually make some models and learn from the embedding system and apply them to the preschool level. So this is what I think.